You guys know your quiz is up. So if you get started, you're just answering the questions, right? You don't have to come up with programs to do it for the most part. Maybe like one you do or something. But most of them, it's like what's the binary representation of 68? Take a piece of paper, find the binary representation of 68, put it as your answer. Your next homework assignment will be out today or tomorrow for you working on. It's going to be assembly. The problems themselves, like in terms of like what you're doing, are not very complicated problems for the most part. They're pretty simple, but the struggle is going to be getting that working assembly code to solve the problem. Also, don't forget you are going to have to run your code in the debugger for it to be able to be run. Otherwise, it's always going to crash and you won't be able to get any output out of it. So today we're talking about common code constructs, so how to translate some common C constructs over to assembly, right? Last time we talked about while loops. So if we had something like, while I is less than, some value, right? And then over here we wanted to do something, some code. What would this look like in assembly code? So for right now, we're going to make answering this question possible, like assume I is in ECX and val is in EAX. So how would we translate this code to assembly? Well, the first thing that we have to do is we have to create a label, right? So here's our label, while start. And then down here, we're going to have while end. Yeah. Okay. Sure. I mean, is it just need bigger or darker? Because if I make it like much bigger, I won't have any more space to actually fit it on the slide, unfortunately.
Okay, could you just make it darker then, please?
Sure. Is that better or do you want it bold?
Yeah, that's good.
Okay.
Thank you.
So, right over here we have while I is less than val, right? That's the code that we're trying to translate. And so we have to figure out how to put that into assembly code. All of our comparisons in assembly, right? What do they have to be against? 0, right? So is I less than val, is that compared against 0? No, right? So how can we rewrite I less than val as compared against 0? Yeah, I minus val is less than 0. And again, normally when I'm translating the code, I'm going to rewrite the above as while true, and then if basically like the negation of the condition, if I is greater than or equal to val, break. Right, so I'm going to rewrite my for loop. So again, the negation of the condition, I'm going to break out of it if it's true. It's the same thing as the original loop. So this has to be, right, the negation. So how do we do the comparison between values? What instruction do we use? Well, it's the comp instruction, and assuming they're long values, like integer values, we use comp L. And then our source is going to be EAX. That's going to be val. And then our destination is going to be ECX. Right? This is going to do ECX minus EAX, which is equivalent to, if I is an ECX and val is an EAX, I minus val. right? And we'd like to leave the loop jump if greater than or equal to the end or while end. And then here we have the other code that we'd like to take care of. Any questions on this translation? So here, right, here's where we do the subtraction. And these jump instructions, what they actually doing the jump based off of, it's based off the result of the last instruction that was run. So jump if greater than or equal to, well, if the last arithmetic instruction that we did, in this case like the comp, if that's greater than or equal to 0, the result of that last instruction, then go to while end. And then we also need to make sure that we go back to the top of the loop, jump to while start. Any questions here? Okay, what do you think a do while loop is going to look like, right? So normally we have something like do some code while, right, like I is less than val. And again, we're going to assume I is in ECX and val is in EAX. So what's the difference between a do loop and a do while loop and a while loop? Yeah.
The while loop, you check your condition first,
Uh-huh.
and while loop, you check your condition last.
Correct. In a while loop, we check the condition at the top of the loop, and in a do while loop, we check the condition at the bottom of the loop. So over here, right, we're still going to need these little labels to be able to jump to. So do while start, do while end. But where should we put the code section that we'd like to run? Well, it needs to come first, right? And now our check is going to be down here. So what would I like to do to compare I less than val, right? And again, I less than val, again, the comparisons have to be against 0. So I less than val, well, that's going to be equivalent to I minus val less than 0. So what instruction will I use to compare the values? What did we use last time? Right, we had to use compare, comp L. If we were comparing bytes, how would this instruction change? Like if we're comparing characters. Would it still be comp L if we were comparing characters? It would be comp B for comparing bytes, because the character is 1 byte big. If we wanted to compare, so if we're comparing bytes, it would be comp B. If we were comparing shorts, which are 2 bytes big, it would be comp W. We're comparing 2 byte quantities. And if we're comparing 4 byte quantities, comp L. And we're working with 4 byte quantities right now. So over here, what we want to do is we want to do I minus val. So what should we write here? Who should come first? EAX or ECX? Right? Again, our goal is to do I minus val. So who comes first, val or I in this instruction? It's going to need to be EAX, which is val, and then ECX, because the way the instructions work, it's always destination, the second one, operation, the instruction, source. So second guy, I, ECX, instruction, comp, which just does subtraction, and then the value that I want to subtract from it, EAX. Val. Any questions here? I feel like I'm just losing everybody. You have no idea what's going on. So just help me out here. How can I help you? You're paying for me to be up here? Yeah.
So for the assembly code, after you write code, you write like there's the hashtag and you have the comparison, right?
Yeah, that's a comment.
Oh, that's
Yeah, the comments are either written as hashtags or /* and then */. So everything between /* and */ will be a comment. Anything else? Yeah.
So the for the nuance side, this is code, and then on the other side, it says view code. You just copy and paste the code.
Well, so the code is going to be the body, right? And it won't be copy and pasted over, right? You're going to have to translate those lines of code, right? There's no freebies, right? You're going to have to translate those lines of code, but like what's going in the body of your state or the body of your loop, again, you're going to do it line by line. And we'll talk about like, if you were doing adding, you'd use like addl. If you're doing subtracting, you'd use subtractl. If we have like more complicated like expressions where it's like a plus b minus c, times d, we're going to have to break it into little units and compute each little subportion because we can only do like one operation at a time, right? If we did like, we can't do a plus b plus c and then assign that to d, right? If we were trying to do this, like d is equal to a plus b plus c, right? That was the code of your body that you want to translate for whatever reason, right? And assume that EDX is D, or D is EDX, A is ECX, B is EBX, and C is ECX. How would you translate this to assembly? Well, take 2 minutes and talk with people next to you and figure out what statement you'd come up with, right, for doing the summation. Again, A is EAX, B is EBX, C is ECX, and D is EDX in doing the translation. So take a minute, talk together, think what you want to do, write it down, come back and get together afterwards. But yes, you will be using adding somewhere along the way. Okay, do we have any suggestions on how we can translate this line of code into assembly? Yeah.
So we thought that you could first set D equal to A and then add B to that answer and then add C to it.
Correct. That's what you want to do. So how can we set D equal to A? how can we take the value from A and move it into D?
We have to do like dollars
So
or
we,
try to do it sometime.
so we want to move the value, right? So to move the value, we use move. So move L. Well, what do we want to move? We want to move EAX. And where do we want to move it to? I mean, EAX. And we want to move that to EDX, right? This is going to be D is equal to A. And when you're writing your assembly code, you put comments next to like almost every single line just so you have an idea of what's going on. Because it'll get really confusing really fast if you're not doing that. So great, we've put EAX into D, and now you want to do your summation. So how can we add B to D? Yeah, add L, and we want to add, what should our first thing be? EBX, and we wanted to add that to EDX, right? So now, right, we have D plus equals B, or overall, right, we have D is equal to A plus B at this point. Then how can we add C to that? ECX to EDX, right? And this is going to be D plus equals C, or in total, D is equal to A plus B plus C to get the entire summation. So it has to be broken down into a couple of different lines to make it happen, because you can only do one add operation or one subtract operation or one multiply operation at a time. Yeah.
Could you explain how to store variable in the register?
Like how to get like a constant value in there, like the value 5 or something like that?
Just how to put a variable.
I mean, you just saw put the value of this register into that register. It's the move. If you wanted to put a constant value, like say 7, move L $7 to percent register name, ECX. That makes ECX equal to 7. Right? If you're working with constants, remember they need to be prefixed with $signs. Any other questions here? Yeah.
Could we just review quickly how you declare like the register, like declaring a variable?
I mean, there really is no declaring a variable. You just say, I'm going to use this register for that. Period. And then you just treat it like the variable.
But like I guess we need to use EAX, like how does it know what it is?
It doesn't. Right? We just said this register will play this role in this program, right? And we, how did we know, right? I mean, like all we said like was like down here was like, you know, D is EDX, BA is, you know, EAX.
But I guess I'm saying, do you not have to ever declare that in the assembly line?
You can, the best you can do is write comments.
I guess I just don't understand so like where.
Like how did they originally get their values?
Yeah.
Like again, if you wanted to put a constant value in them, for example, if A is supposed to be 7, move L $7 to percent EAX. Right? But like is like are you saying like these are like user inputs? How do we get these values from the user if we wanted them like that?
I guess it just confuses me how to know like when you say A and B, just knowing like what you're moving or adding besides what A and B, like what those are, where they came from.
So here, this is just some examples. So we have A, B, C, D, right? They're just made up variable names. You can think of like they're all declared as integers. And so when you get to your assembly code, you're going to have some C code you want to translate. You're going to have variables. And you're just going to be like, this register is going to play this role. Period, right? In my assembly code, I want this register to play the role of I. I want this register to play the role of number of rows. I want this register to play the role of number of columns. And then you just treat it like it is, right? So everywhere you see like number of rows show up, you replace it with whatever your register is that you're mapping it to. You just keep it consistent, yes, right? But all that responsibility is now on you to keep it consistent. The other thing that you're going to find is you only get like 6 registers. A lot of times you have more than 6 variables. And so we will talk about in a little bit like how to put things into memory so that you can free up registers to do some operation. Because like you don't need every single variable all the time. So you can transfer some variable out to memory, do something with what you want to do it with, you know, do the operations on the registers, and then when you need the thing, take it back from memory and put it into register to be able to use it again.
Okay, so for registers, like for EA through EHX, does that mean you only have like 8 working registers at any time in the assembly code?
You only have like 6. You have A through D, ESI, EDI. right? And then like maybe for the first homework assignment you have EBP, so you could use maybe like 7 for the first homework assignment, but beyond that you don't have any more. Any other questions?
Question.
Yeah.
So for EDX, EAX, and all other registers, so do they have different functions, or we can just treat them?
They're just, these registers are just general purpose registers. You can use them for whatever you feel like. There are some special instructions that utilize some specific registers, and we'll show you those instructions later on. But like for right now, A is the same as D is the same as B for you when you're writing your programs, right? The only one that's kind of special right now is ESP, which is the stack pointer. Don't mess with that one. Also, like EDI and ESI, you can't access the sub portions of the register. So you can't access like the 2-byte quantity or a 1-byte quantity within the register, like AX and AH and AL. So over here we did our comparison, right? We did I minus value, and then what should we check on the next line? Right, we need to do some kind of jump, right? So we want to do jump if less than, or do we want to do jump if greater than or equal to, the negation? Because remember, if the jump is true, you're going to go wherever you want to go to. So if this condition is true, what do we want to do? So like if I is less than val, what should happen? Should go back to the top of the loop and do it again. So if I is less than value, where should we go? Back to the start. So this sounds like a less than. We do want to jump if less than. So jump back to jump if less than to do while start. Right? If that condition is true, go back to the beginning and do it again. Any questions? Okay, what about for loops, right? They look something like, for int I is equal to 0, I is less than val, plus plus I, do some code. Right, code's going to be somewhere in the middle. Again, when I'm doing this translation, I kind of rewrite it to be right, which is this is the negation of your condition. So again, I also do this type of loop where I negate the condition. So this first portion of code, this I equals 0, how many times does this part happen? It just only happens once. So we want to put it in our little for loop over here? No, we want to do it right before the for loop, right? So how can we put the value 0 into I, where again I is ECX? Move L, $0 to ECX, right? This is I equals 0. And again, don't forget the $, because $signs mean constants. If you don't have the $sign there, you're going to go into memory at location 0, which is the null pointer, and try to get the value that's there and get a segmentation fault. So don't forget the $signs. Okay, so now after we've set I equal to 0, what do we do next in the C code? right? We set I equal to 0, so what happens next? Well, true, so we're going to go into the loop, and then we have to do our comparison about whether we leave or not. So, can we do I greater than or equal to val? No, so I greater than or equal to val, well, that's again what's equivalent to I minus 0 is greater than or equal to val. And so, how can I do the subtraction? I mean, I minus val is greater than or equal to 0, my bad. How can we do the subtraction? Comp L, EAX, ECX, right? Once again, we have I minus val right there. And then, what do we do next? Jump if greater than or equal to the for end, right? Because this should look a lot like the while loop, because while loops are just for loops with a little bit of extra stuff at the beginning and the end. Now we would do our code body, right? So we do the code. And then after we do the code, what do? What happens next after we do this code body right here? Right, we gotta do the plus plus I. So how do we do plus plus I? We could add L $1 to ECX, or we can use increment, which is inc L percent ECX. This is like the plus plus I, right? Again, you can write the add L. You'll totally get the same effect. But here I just want to add 1, so I'm going to increment I, and then after I add 1 to I, what do? We restart the loop. So how can I restart the loop? Jump to, where do we want to jump to? Or start. Yeah, that's it. Any questions? Okay. Yeah?
So JGE is for jumping to the end.
Yeah.
Jump is for jumping to the
Well, JGE isn't like strictly limited to jumping to the end, and jump isn't strictly limited to jumping to the beginning. Right? JGE is jump if greater than or equal to. Jump if the result of the last operation was true, right? And if I is greater than or equal to val, what do we want to do? We want to break, right? So we want to go to the end of the loop. So JGE to the end of the loop, right? But once we reach the end of the loop, like normally, right, we complete the code body without breaking, where do we want to go to? We want to go back to the start of the loop. So we'll jump unconditionally, always go back to the start of the loop. But if you want to jump somewhere else unconditionally, sure, jump. And you're probably going to see some examples of when we're doing this with like if, else if, else if, else if, else kind of thing. Yeah.
Looks like there's like a colon after for end. What happens afterwards?
Whatever comes after your for loop.
Okay, there's not like any more instructions stored.
Well, I mean, like I'm assuming that we're just trying to translate like little blocks. So a lot of times, like if you had this is how you if you had like your for loop and then you do something else afterwards, you translate your for loop and then after the for loop you would then translate whatever code comes after the for loop, right? So if this was the end of the program, like your program, yeah, you probably wouldn't have anything. But if the next line of code says add 7 to like variable A, well then your next line of code is going to be adding 7 to variable A. Anything else? Why won't this copy in? Oh, what the heck happened here? There we go. So if, else if. So let's assume that the code that we have here was, something like if I is less than, say, 10, code 1. Else if I is less than 20, right? Code 2. Else code 3. Right? Again, the conditions can obviously be more complicated if we need to, and if you we'll talk in a minute how you could do something like if this and that, or if this or that. But how are we going to translate this? And again, assume I is ECX. Maybe it should be like ECX is I. So here we have our if1. And what should we do? Wait. Yeah, we have to compare I against 10, right? So like I is less than 10. Now the question is, do you want to use the positive version of the condition and then jump to the code? Or do you want to use the negation of the condition and jump around the code you would normally do? How many of you guys want to do positive? The code is true, jump somewhere else and execute it. The negation, jump around the code that you would normally do. I think negation slightly wins. I personally think the negation is easier because the code shows up in that area. Whereas like if it's true, you have to go jump up to the code that you want to run, go do it, and then jump to the end of the if else statement, which I think makes it a little bit harder. So our condition is I less than 10, which is equivalent to I minus 10 less than 0. And then its negation is equal to I minus 10 greater than or equal to 0. So the first thing that we need to do is the I minus 10 part. And again, I is ECX, so what do we do for that? All right, just keep going with the patterns you've been doing the whole time. So how do we do the subtraction? How do we do the I minus 10? Yeah, just comp L, but we don't have it in EX right now. Now it's going to be, is it just going to be 10? $sign 10, right? We want the constant value. Again, it's really easy to forget it because it's not syntactically invalid, but it's going to do a lot of weird stuff in your code. So over here, we have comp L10 with %ECX. And again, we were going to work with the negation. So jump if greater than or equal to. Well, if this condition fails, where do we go to? Yeah, we're going to want to go to if2. But if the code succeeds, what do we want to do? Well, I mean, if the negation isn't true, we actually want to do the code. So here would be code 1. And then after we do code 1, what do we want to do? Where do we want to jump to? Yeah, so we want to jump to the end of the what? Yeah, right. Jump to the end of the else. Right? Because you want to go to the very end of the else. It's going to be the end of like the if, else else statement. Right? It'll make more sense probably like when the whole thing's there. So here we have if2. And what do we want to do with if2? Well, we need to do I less than 20, right? Which is equivalent to I minus 20 less than 0, and then its negation is equal to I minus 20 greater than or equal to 0. So what should we do now? $20 with ECX, jump if greater than or equal to the else, right? The else start. Then we can do our code. So we do code 2. And then after we do code 2, jump to the end of the else. So now we have our else start right here. And here, if we're in the else start, right, we just do code 3. And then here we have code 3. And then here we have the end of the else. Does this make sense? And this is like my preferred way of translating this type of expression. Are there any questions? Any questions on the translation of the if, else kind of statement? What would have happened if we had forgotten this line of code? Yeah, it's going to run all of them, right? Do you guys remember switch statements from C? Maybe, roughly. Maybe like remember the biggest mistakes with switch statements is to forget a break at the end of your case. And if you forget the break, you automatically fall through into the next case and do it. That's how you make that happen. You leave just out the jump, and you'll go to the next one. So for translating some of these other things, right, sometimes you end up with, if, A and B and C, blah, 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 blah. How can you rewrite, just in terms of like C code, so if we have, what's another way of rewriting if A and B and C, where A and B and C are some conditions, right? How could you rewrite this without using the and word in C? So how could you rewrite this expression, right, without using the and statement? Again, in Python, in C, just how would you rewrite it? You can't use and at all. Yeah. You can nest the if statements, right? So you could do if A, if B, if C, right? Do stuff. Right, so if A and B and C are all satisfied. But again, that's just writing like an if statement within an if statement within an if statement. And that's really how it gets translated when you're writing your assembly code. It's like if within if within if. Because remember, you stop evaluating as soon as the first one becomes false. Right? So if this one was false, are you going to go into the if statement? No, so you skip all the rest of them. Does anybody need to see translating nested if statements? Or like to see that? Okay. So, right, again, if A and B and C. So maybe our statement over here is if A is less than 20 and B is greater than or equal to 13 and C is equal to 9. We want to do something, right? And let's assume again, for simplicity, that EAX is A, EBX is B, and ECX is C. So what's your assembly code going to look like? Yeah, right. So here we're going to have like, if 1. And let me make it so it stops putting in those extra linear lines. So here we have our if statement 1. And again, this is the a less than 20 line. So how are we going to rewrite this in assembly? Do we want to do a less than 20? Well, no, that's a minus 10 less than 0. And its negation is a minus 10 greater than or equal to 0. So what do we write here? (10) with EAX, and then jump of greater than or equal to, the end, right? No, if it fails, right, because these are nested, right? Remember, if the first condition fails, do we want to do the second one? No, we want to go all the way down to here, to the end. So jump if greater than or equal to the end. Okay. Because again, remember, when we were translating this line of code, first translate it to this. Then once it's translated to this, translate it to the assembly code. So now we have if 2, and our condition was originally b greater than or equal to 13, and its negation when which is equal to b minus 13 greater than or equal to 0, whose negation is then, oops, we're kind of running out of room. What's the negation compared against 0 of this? Right, it's going to be b minus 13 less than 0. So what do we do here? Comp L once again. $13 with EBX, and then to the end. Okay, now we have our third if statement, if 3. And again, like these labels here aren't necessary, but you can still totally put them in just for readability, to kind of understand what's going on, right? Because notice we haven't referenced them at all. We haven't said jump to any of them, but I think it helps reading. So they're there. Okay, so final piece of code, right, is this guy is supposed to be c equals 9. And so that negation and compared against 0 is going to be equal to what? C minus 9 is not equal to 0. So here, it's probably a bit too much spacing. So comp L $9 with ECX, then jump not equal to the end, right? And then down here, what do we do? Well, we do our code. Oops. All right, here's the code. So then here you can finally do the code. And this would be something like, if 3 end, if 2 end, if 1 end. Don't forget the semicolons, and then just end. What? No, but I think it makes it easier to read. So no, or you can put them in as comments or whatever, but I think the indentation here, like, Python doesn't compile without correct indentation. Assembly code is impossible to read without correct indentation, right? So still use your good indents and your good coding style to make things understandable. It becomes more and more important here because you have less and less to work with. Any questions here? Yeah.
I'm sorry, why is compared to 10 not?
Say it again.
The second one, why does it compare to 10 not?
Oh, because I messed up. Now it's 10. Sorry. Any other questions? Okay. Now, how would you translate something like if A or B or C, code? So this now becomes if A or B or C. How would you rewrite this without using OR? So again, not like, how would you retranslate this not into assembly code directly, but how would you translate this into equivalent C or equivalent Python code that did not use OR? So just like if A, if B, if C, right? So if A code, if B code, if C code, like this. Say it again. Yeah. Yeah, there would be some ways of optimizing it when you get to the assembly code, right? But is everybody happy with this? You guys happy? Anybody unhappy? I'm still unhappy with this. Because how many times does the code block get run? What's the maximum number of times the code block could be run now? 3. In the first one, how many times could it be run at most? 1. So how can we make sure that it only gets run exactly 1 time at most? Or at most 1 time? Because if all 3 conditions are satisfied, we would go into each if statement. I'm assuming though, like we didn't want to, like, because you can't break out of an if statement, and we don't want to like return if we were like in a function because we may have other code that we'd like to do. Yeah. Else if, right? Because if you want mutual exclusivity, you only want one of them to be done. Else ifs, right? So if it was if, else if, right? Only one of those happens, right? And this kind of brings us back to the previous problem that we had before, whereas if, else if, else if, else if, and so on. And so the translation is kind of just what we had before. But as was mentioned, we might be able to do a little bit better. Instead of having that code block repeated 3 times, right? We could just have it only show up once. And again, the thing is, in terms of how you would translate this, and again, assume, A is EAX, B is ECX, blah, blah, blah. And then maybe I actually want to copy this one. And now this is just ORs here. How would you translate this code? right? So we could do like the verbatim translation, but that's going to require us to have 3 copies and pastes of the same code. Is there any way we could get around having to do that? There are at least 2 ways I can think of. Yeah? It's maybe not necessarily nested, right? But like here we kind of have like our if one kind of block. I mean, it's sort of nested, but sort of not nested. So like here's like if one, right? Which is again like a is less than 10, who's again once again equivalent to be like a minus 10 and is less than 0. And whenever I actually do this, whenever I'm actually coding like assembly, I literally write this every single time, because when I don't, I screw it up. So if this condition is true, right? So again, compo, $10% EAX. Again, that's the A minus 10. If this condition is true, what should we do? Right? Jump if less than to where? What do we want to do? We want to do the code, right? So like code start. But if it fails, what should we do next? Well, if it fails, we want to check the next condition, right? So if 2 comes right afterwards. Right? So here, our if 2 is b is greater than or equal to 13, right? Which is once again equivalent to b minus 13 is less than 0. Oh, no, still greater than or equal to. Not changing that. And then here we can do compo, $13 with %EBX, and jump if greater than or equal to, right? The condition holds. We want to go to the code start. But otherwise, if that condition fails, what do we want to do? If condition number 3, which is the c equals 9, which is again equivalent to c minus 9 equals 0. So compo $9 against %ECX, jump if equal to the code start. But if this guy fails, what do we want to do? Yeah, jump to code end. And then down here we have code start. And we do our code. And then here's the code end. I know, isn't assembly fun? It was supposed to be something that was so simple. Any questions about this translation? Right, a lot of working with assembly is figuring out how to map your higher level constructs down to the low level things you have to work with. We'll talk about functions a little bit later, but the thing that we have to do next is talk about array translations. So how do you index arrays? So to understand this, we have everybody's favorite, most confusing thing, the advanced indexing mode. Here's what it looks like when you write it in assembly, right? It's going to be D, O, I, and S, where D is the displacement. Probably displacement. And it needs to be a constant expression. O is for offset, and it needs to be a register. I stands for index, and it also needs to be a register. And S stands for scale, and it stands for, and it can be either 1, 2, 4, and maybe 8 and 32-bit mode. I know 8 definitely works in 64-bit. I just never really have a reason to try 8 out in 32. So it literally can be 1, 2, 4, and maybe 8. It cannot be any other value. Does that make sense? The effect of this operation is to do star D plus O plus I plus I times S. Right? Give me memory at location D plus O plus I times S. Give me the value of memory at that spot. Any questions so far about what it does? Okay. Now, the thing that I want to emphasize with displacement is it can be a constant expression. It does not just have to be a constant. So you can do 3 plus 4 times 9 minus 27 times 83, right? That's a constant expression because everything involved in that expression was constants. And the computer can compute that for you. So don't forget that in your translation. Now, each of these values is optional, and they have a default value if they're not given. So not given, it's going to be 0. If it's not given, it's going to be 0. If this is not given, I probably just better copy this. If it's not given, it's going to be 0. And if this one is not given, it's going to be 1. So it defaults to 1 if not given. The other thing that's important to remember is this final little point over here. The amount, or I should say the number of bytes read from memory is controlled by the suffix of the instruction. So if we did something like a move L from this address, right, it's going to read 4 bytes beginning at that address. If we did a move W, it's going to do 2 bytes beginning at that address. If we did move B, 1 byte from that address. So L is 4 bytes starting at the address. W is going to be 2 bytes starting at the address. And B will be 1 byte starting at the address. Also, one important thing to note is at most 1 operand per instruction can be in memory. So if you want to move something from memory to some other location in memory, you cannot do that in a single instruction. How would you go about doing that then, if you can't move something from memory to some other location in memory in a single instruction? Any thoughts? All right, like if I wanted to move something from location 100 in memory to location 200 in memory, I can't say move L 100, 200, because we now have 2 operands that are in memory, location 100 and location 200. So how can I move something from memory in one location to something at memory at another location? How can I transfer the values that are there? Talk with your partner or someone nearby for a moment. Think about how you would do that. How would you move something from one location in memory to another location in memory, right? Given that you cannot put 2 operands that are in memory in a single instruction. So you can't say move L location 100 to location 200, right? So any thoughts how you would do that? I mean, this is pointers, right? Notice there's a dereference right there. This is pointers, right? Right, there's a little dereference there, though it might be a little bit hard to see. There's a star there, right? Again, there aren't any variables. They're just addresses in memory now. So the key here is to use more than one instruction. Move something from memory, location 100, into a register, say EAX, then take what's in your register, EAX, and move to location 200, right? Each of those instructions only had a single operand in memory, but because I wanted to work with two things that were in memory, it took me multiple instructions to be able to do that, right? So you just got to break it down a little bit more. So let's talk about how we can do some different types of translations. Let's say we want to do array at I, right? So we're trying to access array at I. And over in here, on the left-hand side, we're going to assume that AR is a label in memory. And over here, we will assume that AR is in EX. Right? The other thing that we're going to assume is, what do you want AR? AR is in array of, what do you want to do for the first time? Array of ints, array of ints, shorts, bytes. Okay, array of ints. So again, AR is an array of ints for both of them. And then over here, we'll assume that once again, ECX is I. The important thing to kind of note here is about those labels in memory. And kind of like, so this label thing in memory always gets everybody confused because it doesn't like quite jive with what I seem to be saying. So this was the example that we did last week, which feels like forever ago. I know there was something over here. It's under view, right? Highlight mode, assembler. So over here, right? Here was our little array that we were working with, X, right? Notice that when we are working with it over here, X appears in the displacement field, the D field, right? What did I say had to appear in the D field? A constant, right? And so you might ask yourself, how the heck is X constant? That doesn't really make much sense. And when you're referring to the label, you're referring to its location, line it's going to be at. So in this case, it's always going to be at line 15. In terms of like how that translates over to the like machine code that gets created from the assembly code, this means that X always refers to the same location in memory, right? So again, X might be referring to location 500 in memory. So X is the same thing as 500, right? But we just do not have to know where the linker is going to make space for this memory at, or where like it gets compiled together, where exactly in memory it's going to be at. We can just use the symbolic notation X to mean this location in memory, where my array begins. Does that make sense? So the label is a constant, right? And that's why it can appear here in the displacement field, right? So again, are we cool with that? Now, one thing to kind of think about is what's the difference between these two lines? Move X to %EBX and a move $X to %ECX. So again, let's assume that X denotes the location in memory 500. And again, here we have our array of values. It's an array of 12s. if we do this line of code, what value is EBX going to have? Yeah, EBX is going to be 12. What's ECX going to have? It's going to be 500. So when you think about like the labels, if you put a dollar sign in front of it, you're asking for the constant part of that address, or the constant part of the label, which is its location in memory, where it's at. Or again, when we're using this notation here, this is the advanced indexing mode, but we just didn't give any of these three things, right? So we're going to memory at location X, right? Same thing as like exit 0, right? Which is going to be the first thing in our array, the value 12. Whereas where I say $X, I want the constant part of the address. I want to treat it as a constant. So it's its location in memory, 500. Please write this down. But $X is not, $sign does not mean address of. $sign is not address of. $sign means constant, right? And if you're asking for the constant part of a label, it's where it's located at in memory. There is an address of operation, like an address of instruction, and we will talk later about the address of instruction. But a lot of people get confused thinking $sign means address of. It does not mean that. It just says constant. And constant part of a label is its location in memory. So it will be an address. We okay with that? Just really make sure you have that down before you start your coding, because it's going to make you really confused otherwise. Okay, so how can we translate this line of code given the following assumptions, right? If AR is a label, right, and we just said labels are constants, what field is it going to have to go into? Actually, we should say, step one is, how can I rewrite this expression, AR at I, without any brackets? It's star AR plus I. Does this look at all familiar to this format? Looks pretty dang similar, right? And that's why we're going to be using the advanced indexing mode to pick out the elements that we want. So D plus O plus I times S. So over here, if we look at this expression on the left-hand side, AR, is that a constant or a register? On the left-hand side, again, assuming that AR is a label, like you just saw with X. Is AR a constant, or is it a non-constant? Constant, not constant. It is constant, right? Because again, labels are constants. They just tell you this location in memory. You can't move the label. It's stuck there, right? If this, label refers to the location 500 in memory, it always refers to the location 500 in memory. It cannot change once the program gets started. So it is a constant. What about I? Is that constant or non-constant? Constant. Non-constant, right? It's not constant, right? It's actually in a register. You can see from our assumptions above. So how do we translate this piece of code into assembly, right? We have the D, the O, the I, and the S. And let's say that we're trying to do our statement over here is AR at I is equal to 55. So they can get a full statement. So again, D has to be constant. So what part of our expression has to go here? AR, right? So AR goes here. What do we want to do? So I, do we want to put it into O, or do we want to put it into the I field? Sure, we'll put it into the I field, and it kind of just stays there. So that's going to be ECX. Now, do we need to put something in the O field? Again, we want to just do AR plus I, right? Are we currently doing at least AR plus I? Yes. So nothing in the O field. Scale field. 1, 2, 4, or 8. 1, 2, 4, 8. So for those of you that say 1, why do you pick 1?
It seemed like it was mathematically right.
Well, so here, right, this is how you'd rewrite the expression, but here, right, we have an array of ints, right? So if our array begins at location 100, our first integer begins at location 100, right? Like array at 0 is at location 100, right? And it's actually going to occupy bytes 100, 101, 102, and 103. So your next integer in the array begins at location 104, right? So 104, 5, 6, 7 is your next one, right? It's taking up 4 bytes. Our next guy would be at 108, 109, 1010, 111, right? So every time we want to move a single integer, how many bytes do we have to move? 4 bytes, right? So our scale needs to be 4 because we're accessing an individual bytes in memory. So this is going to be 4, right? And since we're doing AR at I equals 55, we want to do a movl $55 to AR at this location. Any questions here? Okay, quickly. So over here, we copy things over. So over here on the right-hand side, is AR constant or non-constant? Constant? Non-constant. It's not constant on the right-hand side because AR is in EAX, right? You have to read the conditions first to answer the question. Here it's an EAX, here it's a label in memory. So over here, AR is not constant. And again, it's also not going to be not constant for I. So here, movl 55, can we put AR here anymore? No. Where can we put it? In the offset field, right? Because again, we still want to do AR plus I, right? We want to start at AR and then move I integers past the beginning. If we put something in the O field, it's going to be O, right, plus I times S. And that will move you to the correct location. So AR shifted from being the label into a register, and so it moved from the displacement field to the offset field. Okay, we're out of time. We will continue talking about the advanced indexing mode on Thursday. And after that, we will do some examples like matrix addition or like string length or concatenation, stuff like that.